One of the simplest ways to describe the structure of a molecule is by drawing a Lewis structure. But before you can draw a Lewis structure, you have to be able to recognize how many valence electrons each element has. This is pretty simple with the periodic table. Basically, you number left from right. Anything in the first column has one valence electron. 2, we can skip all of the transition metals over to boron. 3, 4, 5, 6, 7, 8. For example, if we wanted to look at hydrogen, we can see it's in the first column. It has one valence electron. We could draw a Lewis dot structure of hydrogen, draw its symbol, it gets one valence electron. Because each unpaired electron in an element is going to be paired up, we can say it's going to form one bond. Another example, carbon. Carbon is in the fourth period, the periodic table, so it'll have 4 valence electrons. To draw a Lewis structure of this, we have carbon, 4 unpaired electrons, one on each side. This tells us we're going to form 4 bonds with carbon. Finally, boron in the third period, so it has 3 valence electrons, 1, 2, 3. It will form 3 bonds. So let's apply this to a simple problem. Draw a Lewis structure for a compound consistent with the formulas below. CH4. First off, you should recognize that carbon has 4 valence electrons. Each hydrogen atom has 1. Carbon's going to make 4 bonds. We have 4 hydrogen atoms. So on each side of the carbon, we will have a single bond to a hydrogen. Each of these bonds represents the pairing of 2 electrons. Next example, ammonia, NH3. Nitrogen has 5 valence electrons, which tells us it's going to make 3 bonds, one to each of these 3 hydrogen atoms. Finally, we could take a look at CO2. We know that carbon has 4 unpaired electrons. It'll make 4 bonds. Oxygen has 2 unpaired electrons. It has 6 total valence electrons. So oxygen will make 2 bonds. Each carbon will make 4. So if we have 2 oxygens, we will have 2 bonds between each oxygen atom and carbon. Moving on to some more organic compounds, C2H6. Whenever you have carbon in organic chemistry, the simplest thing to do is to bond them together immediately. We know that each carbon will make 4 bonds total, so we have 3 more bonds to make, giving us a total of 6 hydrogen atoms. Next example is methanol, CH3OH. In this case, the CH3 implies that the carbon is bonded to 3 hydrogen atoms immediately. Then oxygen, then a hydrogen. Oxygen has 2 lone pairs, so we're finished.